morning to one and all. This is Dr. K. Pushpa Rani, Associate Professor, Department of CSC, MLR Institute of Technology. In this video, we are going to discuss about the recurrence relations. So, what is a recurrence relation? What are the methods to find the recurrence relation? And in this video, we are going to discuss about the first method for the recurrence relation. So, what is a recurrence relation? Recurrence relation is an equation. Okay, it is an equation that defines the function. It is one type of method to analyze the time complexity for the recursive algorithms. What is a recursive algorithm? Means the function which is calling repeatedly is called as a recursive algorithm. So, in the case of recursive algorithm or it is a recurrence relation, it consisting of two cases. One is called as a general case. Another one is a base case. Base case is nothing but a initial condition. That is, for example, for I equal to 0, I less than n, I plus plus. That I equal to 0 is called as initialization or it is the starting value. The starting value is called as a base case and we have to repeat the for loop up to n, that is called as a general case. We have to start from the base case and the procedure is repeated from general case. Sometimes we have to start with the base case and it is repeated up to n terms, then it is a general case until the general case has to be reached. That is one way. Another way is we have to start from the general case and it is repeated until the base case is satisfied. That is also one type of method. But whether it is a base case to general case or general case to base case, our main objective is find the time complexity of an algorithm. That is why we need to analyze, why we need to measure for analyzing of an algorithm. Whether it is the best algorithm or it is a worst algorithm, that's why we need to measure the time complexity. There are three methods for solving the recurrence relation. One is called as a substitution method. Second one is a recursion tree method, that is also called as a iterative method. And third one is a Master's theorem. These are the three methods to find or solving the recurrence relation. In the substitution method, again there are two classifications. One is a forward substitution. Second one is a backward substitution. In forward substitution, start from the base case and it is repeated until the general case has to be reached. But in case of backward substitution, start from the general case and it is repeated until the base case is satisfied. In this video, we are going to discuss about the substitution method by using forward and backward substitution. But compared to forward, most of the cases we are going to find the solution for the recurrence relation by using backward substitution. Only for rare cases, we are going to use the backward substitution method. So, in the case of substitution method, first we need to guess the form of solution. But in the case of substitution method, we need to substitute the value repeatedly until some formula has to be derived. Okay, we should not simplify the recurrence relation. We are going to calculating the what is the derived formula based on the given equation that we need to calculate in the case of substitution method. So, by the help of mathematical induction also we have to prove. With the help of mathematical induction we need to find the solution for the recurrence relation, but we need to derive the equation. So, based on the substitution method we need to derive the equation, but we should not simplify the expression. So, find the time complexity using the substitution method. So, here it is a T of n equal to T of n minus 1 plus n, where T of 1 equal to 1, that is the base case. So, we have to start from the base case and it is repeated until the general case has to be satisfied. So, take the recurrence relation T of n equal to T of n minus 1 plus n, that is equation number 1. So, we have to start from the T of 1, n equal to 1, T of 1 equal to t of 1 minus 1, that is d of 0 equal to 1 plus 1, that is simplified as t of 0 plus 1, that is 0 plus 1 equal to 1. Okay, then n equal to 2. So all values are substituted in equation number 1 only. T of n equal to 2. T of 2 minus 1 means t of 1 plus 2. T of 1 is 1 plus 2. This is the forward substitution. We have to start from the base case and it is repeated until the general case has to be satisfied. Then n equal to 3. Then t of 3 equal to t of n minus 1. N minus 1 means t of 2 plus 3. We know what is t of 2, that is 1 plus 2 plus 3. If it is repeated for nth term, then we are going to get t of n minus 1 plus n. So first term t of 1 we are going to get 0, 1. T of 2 we are going to get 1 plus 2. For the third term 1 plus 3, 1 plus 2 plus 3. Then for nth term t of n minus 1 plus n. That is repeated 1 plus 2 plus 3 and so on, n minus 1 into n minus 1 plus n. So we know the equation for sum of n natural numbers, that is equal to t of n equal to n into n plus 1 divided by 2. That is n square plus n by 2. We'll get n square by 2 plus n by 2. So we in the case of time complexity, we always ignore the constant values. We always measure the time complexity in the higher order. So n square is the higher order compared to n. T of n equal to big O of n square is the time complexity for the given recurrence relation. T of n equal to T of n minus 1, you have to start from the base case, that is C of 0 equal to 1 is the base case and it is repeated from the nth term, n is the general case, and we have to derive the equation that is called as n into n plus 1 by 2, that is n square by 2. We always consider the higher order is the time complexity, then T of n, higher order is the time complexity, then time complexity always measured by using the worst case. T of n equal to big O of n square is the time complexity for the recurrence relation. T of n equal to T of n minus 1 plus n. Consider the second example. Find the time complexity using backward substitution method. In backward substitution, what is the time complexity? We have to start from the base case and start from the general case until the base case has to be reached. That is T of 1 equal to 1. Until we get 1, we are going to repeat the equation. Consider the equation as T of n equal to T of n minus 1 plus n. This is equation number 1. Substitute, we know what is n value. So substitute n equal to n minus 1 in equation number 1. N equal to n minus 1. That means in the place of n, you have to substitute n minus 1. N minus 1 equal to T of n minus 1 becomes plus n minus 1. That is implies as T of n minus 2 plus n minus 1. We know what is n minus 1. Then we will find n equal to n minus 2. In the place of n, how to substitute n minus 2 in equation number 1. T of n minus 2 equal to T of n minus 2 minus 1 plus n minus 2, that is equal to T of n minus 3 plus n minus 1. In the place of T of n minus 3, we'll get T of n minus 4 plus n minus 3. This process is repeated for T of n equal to, how to get T of n minus 1 plus n. We know what is t of n minus 1, that is t of n minus 2 plus n minus 1 plus n. We know what is t of n minus 2, that is t of n minus 2 is t of n minus 3 plus n minus 2 plus n minus 1 plus n. So we know what is n of n minus 3, t of n minus 4 plus t of n minus 3 plus n minus 2 plus n minus 1 plus n. So this process is repeated for t of n minus t of n is, so here it is k value is 1, 2, 3, 4. First term is k, that is nth term n minus 1, n minus 2, n minus 3, n minus 4, that is repeated for t of n minus n. So that is repeated 1 equal to 1, 2, 3, 4, n minus 3. N minus 3, that means n minus 4, n minus n, after that it is repeated for n minus 3, n minus k, k equal to n, that means we are going to get n minus k minus 1, okay, k, so 4k minus 1, then k minus 2, t of n minus k minus 2, like that it is repeated for nth term, that is n k equal to n. We'll get t of 0 plus 1 plus 2 plus 3 and so on n. T of 0 is, t of 0 value is 1. T of 0 is 1. We'll get 2. T of 0 is 1 plus 2 plus 3 and so on n. That is n into n plus 1 divided by 2 will get n square by 2 plus n by 2. So we have to substitute, this process is repeated for k values, then we'll get equation as big O of n square is the time complexity. Big O of n square is the time complexity. Whether we are using forward substitution or backward substitution, we'll get the same thing, but what is the time complexity is big O of n square. Consider one more example. T of n equal to 2t n by 2 plus n. Find the time complexity using backward substitution. Consider t of n equal to 2t n by 2 plus n is equation number 1. We know what is n, we don't know what is n by 2. So in the place of n, we are going to substitute n by 2. That is t of n by 2 equal to 2t. In the place of n by 2 becomes n by 4 plus n by 2. Then we know what is n by 2. In the place of n, you have to substitute n by 4 in equation number 1. N by 4 equal to 2t n by 8 plus n by 4. Next, in the place of n, you have to substitute n by 8. So, we have to repeat for up to 3 terms at least. T of n by 8 equal to 2t. In the place of n, substitute n by 8. N by 8 into 1 by 2 will get n by 16 plus n by 8. Substitute equation 2, 3, 4. In equation number 1, we are going to get some terms. Okay, that is T of n equal to 2t n by 2 plus n. We know the value of t of n by 2. That is equation number 2. So, 2 is written as it is. In the place of t of n by 2, 2t n by 4 plus n by 2 plus n, repeat the leftover term. Okay, so that is we have to written as 2t 2 square t power n by 2 square plus 2n into 2n will get 2n and get cancelled, 2 get cancelled, n plus n is 2n. Next 2 square in the place of t of n by 2, that is t of n by 4, we have to substitute equation number 3. 2t n by 8 plus 2n, so plus 2n. That means we are going to get 2 cube t of n by 2 cube plus 4 by 4 plus 4 into 2, 8n. That is, so the third term is 2n. So that is n by 2. N by 2 will get 2n. The third term is 2 square. 4 by 2 will get 3n. Will get 3n. Okay. So like that it is repeated for nth term. T of n equal to, so first term is 2 square. Second term is 2 cube. Then 2 power 4. Like that we are going to get 2 power k t of n by 2 power k plus kn. So we know that to n equal to 2 power k equal to log n base 2. So we need to substitute 2 power k of t of n by n plus kn. 2 power k t of 1 plus kn. 2 power k t of 1 is 1 plus kn. 2 power k is log n, so we can write it as n into 1 is 1. K value is log n log n base 2. So which is the highest term? N log n is the highest term. N log n is the highest term. So we are going to consider n log n. The time complexity t of n equal to n log n base 2 is the time complexity. So it is always measured in the big O notation. Big O of n log n base 2 is the time complexity for the given recurrence relation. Consider one more example. Find the time complexity using backward substitution method. That means what is the substitution method? Means repeatedly you have to substitute until the sum equation has to be derived. So write t of n equal to t of n by 3 plus c. That is equation number 1. What is the base case here? T of 1 equal to 1 is the base case. We need to repeat until the sum base case has to be repeated. Until some base case has to be repeated. So in the place of n, substitute n by 3. So that is t of n by 3 equal to t of n by 3 into 1 by 3 becomes n by 9. Plus constant is c only, that is equation number 2. Right, at least 2 to 3 terms. We know what is n by, we know what is n by 3. Now we need to find n by 9. N equal to n by 9 is substituted in equation number 1. T of n by 9 equal to t of n by, so that is n value is 9, 9 into 3 27 plus c. That is equation number 3. Substitute equation 3 in equation number 1. Take equation number 1, t of n equal to t of n by 3 plus c. We know what is t of n by 3. That is already derived in equation number 2. T of n by 9 plus c. So plus c, it is already there, plus c. That is nothing but t of, can I written as n by 3 square. This is plus, so that is 2c. Next, what is n by 9? T of n by 27 plus c. So already plus c is there. So plus c, again plus c, 2c is there. That is equal to t of n by 3 cube plus c, 3c. This process is repeated for n terms. That is T of n equal to T of n by 3 power k. That means first term is 1c, second term is 2c, third term is 3c, fourth term is 5c, like that kc. We know that what is k? K equal to n equal to 2 power k. But in the place of 2k, 3k is there. So that is T of n by n plus, what is k? K equal to log n base 3. Log n base 3 c. C log n base 3, that is T of n by n means T of 1 plus C log n base 3. Therefore, T of 1 equal to 1, because when the base case is satisfied, we have to stop the iteration. 1 plus C log n base 3. So 1 plus log n, which is the higher term, C log n base 3 is the highest term. T of n equal to big O of C log n base 3 is the time complexity of the given recurrence relation. So we need to follow the two methods, that may be either forward substitution or backward substitution. In forward substitution, we have to start from the base case and it is repeated until the general case has to be derived. But in the case of whether it is a substitution method or whatever it may be, but our objective is we are not going to simplify the expression, we are going to derive the equation. In the case of backward substitution, we have to start from the general case and it is repeated. This is the general case and it is repeated until the base case has to be satisfied. Once the base case is satisfied, we need to derive the equation and find the time complexity. So there are three methods to find the recurrence relation. One is a substitution method. There are two methods are there under substitution. One is a forward substitution, another one is a backward substitution, and we already discussed some examples on this method. Thank you.